Okay, if I have a fraction 3/4, that whole fraction is positive. Another example, or a better example, would be 12/4. Okay, the whole fraction is positive, and the whole outcome is also 12 divided by 4 is 3, is also positive. Now in this case, let's do negative 20 over 4. Notice that there's one negative symbol. Now the way that it's written, if I ask you, well, what's negative? Is it the 20? Is it the 4? It doesn't matter. Okay, what I want you to understand is whether I write it this way, where the negative symbol is right in the middle next to the fraction bar, or if I write it as negative 20 over 4, or if I write it as 20 over negative 4, these all mean the same thing. These are all equivalent to each other. Okay, there's only one negative symbol, which means the whole fraction is negative. Because when I solve this, 20 divided by 4 is 5, and if there's one negative, I know that the outcome is negative 5. Okay, so it doesn't matter whether I write it this way, where the negative symbol is right next to the fraction bar, so it's right in the middle. If I put the negative on the numerator, or if I put the negative on the denominator, all three of these fractions mean the same thing. The only time it's different is if I write it out this way. Negative 20 over negative 4. Now in this case, these negative symbols actually cancel each other out. And I'm left with 20 over 4, which just gives me positive 5. Okay? If you don't see the difference here, talk to me. But hopefully you can see the difference where here we only have one negative symbol in the fraction, and here we had two negative symbols. So I want you to really look at that and let that kind of soak in. So let's say instead of just integers like we just did, now we're going to multiply fractions. Well, here, let's say I did 3/2 times negative 2/3. Well, we know when we multiply fractions, we don't need a common denominator. You just multiply straight across, right? So that means I'm going to multiply my numerators, and then I'm going to multiply my denominators. 3 times 2 is 6. 2 times 3 is also 6. Now what you did need to realize is this 3/2 right here, this is a positive 3/2. This 2/3 is a negative 2/3. And a positive times a negative is a negative. And then we can go a step further with this problem specifically, because 6 over 6 is 1, and since there was a negative here, my answer is negative 1. Okay? I can do another problem. Let's say I had negative, let's do 4/5 times negative 7/9. Okay? Now, again, it doesn't matter where the negative is. There's one negative on 4/5 and there's one negative on 7/9. So that means that my answer when I multiply negative times a negative has to be positive. So I can keep that in mind, or I can do that after. It doesn't matter. Now I just multiply straight across. Well, 4 times 7 is 28, numerator times numerator. And denominator times denominator, 5 times 9 is 45, okay? And that's my answer. You might be asking yourselves, well, do I have to reduce? In this case, there's nothing to reduce. But in most cases, unless I specify, you don't need to reduce. But if I tell you to write your answer in lowest terms, then yes, you will have to. So how about this problem? What's happening here? There's 3 negatives in here, right? Well, you can do a couple things. What I would do in this case is understand that if I'm looking at this fraction, right? Fraction bar just means division, right? Well, a negative divided by a negative is just a positive. So I can rewrite this problem. I can rewrite it as negative 3/7. Now, does it matter where I put the negative, whether I put it next to the 3, the 7, or next to the fraction part? No, because the whole thing is negative. If I want to keep it next to the 7, great. Otherwise, I could have put it anywhere, and it would not have changed anything in terms of my outcome. Times, we said a negative divided by a negative is a positive, so instead of negative 1 over negative 6, I can change that to 1/6. And now, when I look at my fractions, I have a negative times a positive, right? I'm multiplying a negative and a positive. So my answer has to be what? It has to be negative. And now I multiply straight across. Numerator times numerator, 3 times 1 is 3. 7 times 6 is 42. Now this can actually be reduced. If you would like to reduce it, great. What happens when I reduce this? I get negative 1 over 14, okay? Because I can reduce both of these numbers by 3. 3 divided by 3 is 1. 42 divided by 3 is 14. So whether you gave me this answer or you gave me this answer, same thing. All right, let's do 1 or 2 more problems. This time we're going to do division. Hopefully you remember how to divide fractions. So if I have 2/3 divided by negative 3/4, remember an algorithm to use here, when you when you divide fractions, it's the same thing as multiplying by the reciprocal. So what happens here is you change this division symbol into multiplication. This 2/3 stays 2/3 because it's our starting point. Your starting point's never going to change in most cases. And then you're going to get the reciprocal of 3/4. Remember, a reciprocal just means that you're going to take the fraction and you're going to flip it, okay? So if it's negative 3/4, it's now going to be, let's keep this red, it's now going to be negative 4/3. The reciprocal of 3/4 is 4/3, and since it was negative, the fraction is going to stay negative. And now I multiply. 2 times 4 is 8. 3 times 3 is 9. I had a positive times a negative, so my answer is going to be negative 8/9. And you're done. Okay? Remember, when you divide by a fraction, to get your answer, you can just multiply by the reciprocal. Done deal. Let's do one more That's not going to be fraction related this time. Let's go back to integers. What happens if I do this? -1 times -1. What does that give me? It gives me +1, right? Because a negative times a negative is a positive. Well, now let's say I take that +1 and I multiply it by a -1. What is that going to give me? Positive times a negative is a negative. And if I take that -1 again and I multiply it by -1, I'm just going to get +1. And if I keep going and multiplying each answer by -1, it's just going to keep changing, right? I'm going to get 1 times -1, and I'm going to get -1. So notice it goes positive, negative, positive, negative. Well, knowing that, what happens if I combine all this? What do I mean by that? What if I did, instead of doing -1 times -1 times -1 in two separate problems, what if I literally just put down -1 times -1 times -1? What's my outcome here? Thoughts? So if I'm looking at this, I'm noticing, well, if I just look at the first part, this is the same thing as what we did here. Negative times a negative gave me a positive. And I took +1 times -1, which gave me -1. Okay, so the answer to this is -1. Now what if I went a step further? Here, notice that there's 3 -1s that we just did. We multiplied -1 times -1 times -1. There were 3 of them, and it gave me -1. When there were 2 of them, it gave me +1. Well, what happens when there's 4 of them? What does that give me? Well, what's -1 times -1? We just solved that. It was +1, right? Right here. And then +1 times -1 gave me -1. And then -1 times -1 gives me +1. So here there's 4 -1s, and it gave me a +1. Let's go a step further. 1, 2, 3, 4, 5. What do you think is going to happen here? When I had 3 -1s, it was -1. When I had 4 -1s and I multiplied them, I got +1. Now I've got 5 -1s. What's going to happen? I get a -1 again. So what do you notice? Forget about the ones. What about the number of negatives? How many negatives were here? 3. How many were here? 4. How many were here? 5 negatives. Again, we're ignoring the ones. Well, 3 negatives gave me -1. 4 negatives gave me a positive. 5 negatives gave me a negative. 6 negatives are going to give me what? A positive. Notice it keeps switching. Well, which types of numbers give me a negative outcome? How many negatives do I need to get a negative outcome is what I should have said. How many negatives do I need to get a negative outcome? Good. If I have, let's go with red. If I have an odd number of negatives, I'm going to get a negative outcome. If I have an even number of negatives, I'm going to get a positive outcome. Okay? This is always true. But again, this is always true for multiplication and division only. So this is for multiplication and division only. Okay? Does not hold true for addition and subtraction. This only holds true for multiplication and division. Okay, if you have any questions, let me know.